Another way on number 17 to find the rate of change is you could just find the rise and run. In this case, it's going down and over, which would be down 160 over 4, which still gives you negative 40 when you're done. The smallest watermelons weigh 11.8 pounds. The large ones weigh 23.1. C equals 59 cents, or 59.59. P represents the cost of the watermelon at 59 cents per pound, where P is the pounds. What is the range of CP? Range, remember, is the output. And in this case, the output is the cost of how much you're going to pay for the watermelons. So P is the input. And so you're saying, what's the smallest amount of money that I'm paying, and what's the greatest amount of money that you would pay for the watermelons? If I was talking about the domain, then the number of pounds I'm working with, or the input numbers in for P, those are the numbers plugging in, then I would be talking about the domain, which would be 11.8 and 23.1, and that would be answer A. That's the domain, which is not what we want. We want the range, we want the output. So if I plug in 11.8 pounds and find the cost, the output cost, I end up with 6.962. And if I switch it and put 23.1 times it by the cost of 59 cents, that gives me an output of $13.06.29. And we're talking about money, so that's why it rounds to 6.96 and 13.63. And this is the output, or the cost, right? It would not be answer C because that has a P with it, which P is the input. It's not the output. Range is output, domain is input. So in this case, it's going to be answer D. As x increases in value, which function will eventually have the greatest value? It's a little bit hard to see from the tables right now, so I would suggest continuing the tables until you can see clearly which one will be the most. If I do 4 to the power of 3, right, I put a 3 for the exponent, that gives me 64. If I put 4 to the power of 4, I get 256. And I just went to 5. We can keep going to 6 if I need to, so we'll see. If I put 4 to the power of 5, I get 1024. If I put 3 to the power of 4, I end up with 81. 4 to the power of 4, 256. And 5 to the power of 4 gives me 625. So right there, I start seeing a difference, right? After the number 4, I see that our exponential function is the one that's going to increase faster. Last of all, over here, if I put in a 3 for x, 4 times 3 is 12. 4 times 4 is 16. 5 times 4 is 20. So it's definitely not this one. Linear is not growing very fast, so it's our exponential growth here. This is the exponential growth is going to be the fastest. And that's true all the time. Exponential growth grows fast. And last of all, we got this number 20. When Mary runs, she runs 4 miles in 32 minutes and 6 miles in 52 minutes. The number of minutes it takes Mary is represented by m of t equals 10 times t minus 8. That should say the number of miles. So the number of miles, no, that would be minutes, huh? She runs 4 miles in 32 minutes. Oh, right. Sorry. I had to think about that one longer. 4 miles in 32 minutes and 6 miles in 52 minutes. So you want the output of how many minutes does she go with 7.5 miles. So 7.5 miles is our input. All we're going to do is plug it in for the t, minus 8. This is 75 minus 8 gives me 67 minutes. So for her to run 7.5 miles, it's going to take 1 hour and 7 minutes. Very long time. Well, not if you're going 7.5 miles, but